Let's go ahead with Sachit Shankar.
All right, give me a second.
Sure. Yes, you want to just adjust your webcam a bit so that it shows more of you. Yeah, that looks good.
So my name is Sachit Shankar. I'm from Wilmington, Delaware, and I'm in the 10th grade. So my research paper is on the topic of nanosponges for environmental remediation, specifically for the removal of contaminants from the water, air, and soil. So I'm just going to be talking about the table of contents. So first, in the introduction, I'm going to be talking about the environmental pollutants, their types, their sources, and how they impact the environment and all living things. Then I'm going to be talking about the literature review, which is just examples of nanotechnology for environmental remediation. And then for the methodology, I'm going to talk about the synthesis methods for nanosponges. And to wrap up in the conclusion, I'm going to be talking about nanosponges and why they should be used for environmental remediation over other nanotechnology. All right. So what are environmental pollutants? Well, they're any material that negatively affects the air, water, soil, or living things. And it can be physical, chemical, biological, or radioactive. And pollution can be caused naturally through volcanic ash. And it can also be caused by humans through runoff and waste by many factories. So the objective was to research upon nanosponges for environmental remediation. I noticed that when I was researching that nanosponges were really good as a drug delivery system because they had high surface area. They could hold a lot of medication that could be used in the body. And I thought, why can't this property of nanosponges be used for capturing environmental pollutants and getting rid of them? So that's how I kind of came up with this topic. So number one, I'm going to be talking about nanotechnology, environmental remediation. So nanomaterials are very small materials that have lots of unique properties, especially like their large surface to area ratio, and they are very reactive. So one example is the titanium oxide nanoparticles. They are metal nanoparticles that are low cost, non-toxic. They have properties of gas sensing, waste treatment, and air purification. All right. So what are nanosponges? Well, nanosponges are three-dimensional cross-linked polymers, which are basically one singular micrometer in size. They are a unique type of nanotechnology that are known for their high surface area, as I've said before, and their modifiable surface chemistry, which just means that they can be used in a variety of applications. They're very useful for like capturing and removing various types of pollutants in the water, air, and soil. And currently they are being applied to wastewater treatment and oil spill restoration and to remove poisonous gases from the air. And I think nanosponges for environmental remediation are just in general a more effective solution than when compared to other types of nanotechnology. So for the methodology, I'm going to be talking about the synthesis of nanosponges. But before that, I wanted to say that I use a lot of peer-reviewed research papers published on like EBSCO, and I use recent research by looking and noting down their publication dates. So for how are nanosponges created? There are many methods for synthesis for nanosponges. So I've decided to include two. So the first one is the green synthesis method, which utilizes natural polymers and provides a faster metallic nanoparticle production by offering environmental friendly, simple, and an economical approach. And the second synthesis method is ultrasound assisted synthesis. And this one, using sonification, this method creates nanosponges by allowing an interaction between polymers and cross-linkers to occur without the need for a solvent. And this is how uniformly sized nanosponges are produced. So I included a figure on the right, and this is from an article by the National Library of Medicine. And this is showing the ultrasound assisted synthesis method. So this is kind of my inclusion in conclusion, but why are nanosponges why should nanosponges be used for environmental remediation? Nanosponges are great in the environment because one of the key aspects is that they can bind to particles and soak them up very easily, especially when it comes to oil. Their high surface area allows them to effectively absorb and remove oil contaminants and other thick contaminants from water bodies. As I said before, they have very good high surface area, so they have great absorption capacity, and they have great modifiable surface chemistry, more than when compared to other types of nanomaterials. And and that makes them very adaptable for the use in other applications in other fields. So I want to talk about my research experience. So Ms. Lilova helped me understand the science behind nanosponges and aided me in finding the correct articles. And she really helped me understand the significance of nanosponges in today's world. When it comes to essay writing, Professor Virgil helped me to really understand how to write a research paper. Before this paper, I didn't really write any research paper, and I didn't really know how to do the structure of it. And Professor Virgil really helped me with learning about the structure and really just conveying my argument by supporting it with lots of evidence. And Professor Virgil helped me with like public speaking by always engaging me and everyone in discussions during our classes. And thank you for listening.
Amazing, Sachit. Excellent topic. I mean, I have to pinch myself and tell myself that these are high school students, not experts in the fields. So great job, Sachit. Question from Dr. Christina.
Yeah, so the nanosponges are very versatile, which we found out. And you mentioned their usage, of course, in environmental remediation and, of course, the biomedicine. But are there any other applications, the other fields you encountered when you're doing your?
I mostly only saw like in biomedicine, and just environmental. I didn't really get to see much in other fields.
Okay, as they're used as sensors, potentially can be nanosensors as well.
What did you say?
They can be nanosensors, potentially can be used as nanosensors also. So they're in the textile materials.
Yeah, they can. Yeah, I did talk about
the
that.
textile,
yeah,
the textile materials. I remember the textile materials because this was a very interesting application.
Yeah.
Yeah. Okay. Thank you.
Thank you.
Okay. So great job.